Okay, so now we kind of have an idea of what it means to break down roots, or I'm sorry, build up roots into an equation. We're going to be breaking down an equation into its roots. And so that reverse process is actually what we're most interested in. And so we're going to be talking about solving equations by factoring. We did the graphing method. We used tables off a calculator. Factoring is going to be the most practical. It's going to be the one that you end up using most frequently. So here's just an example. Let's say we factor and we end up like this. We have x plus 3 and then times x minus 5 equals 0. So factoring has been done before. I know you guys have seen it. It's always something that people have trouble with. So we're going to go through a lot of examples to kind of refresh your memory on factoring. So say you come up with this. If you know that this thing times this thing equals 0, well, we have this, it's called the zero factor property. It tells us that the only way for two things to multiply together and equal 0 is if one or both are equal to 0. So that means then x plus 3 must be equal to 0, or x minus 5 must be equal to 0. And then you'd solve, you get x by itself. Those are your answers. So that's what it means to solve an equation by factoring. So we've got a number of different methods that we're going to be looking at. The first method, this section in particular, we're going to be factoring out a GCF. And the GCF stands for greatest common factor. This is something that you won't specifically be told to do. It'll never say like, hey, solve this by factoring out the GCF, but it's something that you should be looking for every single time because it's something that people forget about a lot, but it's something that can kind of save your factoring. Like it can make things a lot easier when it looks like there's nothing else you can do. So first thing, when you're factoring, you want to make sure that everything is on one side of the equation. See how we just have 0 right here and 0 right here. That's the form that you need to be in order to factor. So with this one, we're going to look and see, notice that this term and this term actually both have something in common. So look at the 9s. 9 and 3 are both divisible by 3. So that's part of the GCF. And then y squared and y are both divisible by y. So the GCF is 3y. So what you do when you're factoring out a GCF is you write the GCF on the outside and then set up a set of parentheses like this. And that's almost like distributing. It's like the opposite of distributing. So instead of multiplying everything here by a 3y, we're going to be dividing everything here by a 3y. So if you divide this expression by 3y, 9 divided by 3 is 3. Y squared divided by y leaves you with a y. So think of the way that distributing works. If you were to multiply this back in, you'd end up with this 3y squared. And then plus, when you start with 3y, if you divide it by 3y, all you're left with is 1. Okay, so now this technically counts as a factor, and this is another factor. So now we're at this point. So what you do is you set each of the factors equal to 0. Okay, so you set 3y equal to 0. That's this one right here. And then you also set this one equal to 0. And then you solve. So this one, to get the y by itself, all you need to do is divide by 3. So 0 divided by 3 is still 0. So one of our answers is 0. And then here we start by subtracting 1. And then we have 3y equals -1. And to get y by itself, we divide by 3. So our second solution is -1/3. So two solutions for this equation. So that means if you plugged in 0 or plugged in -1/3, that would make this equation true. When you're checking your answers, it's always a great idea to use that calculator check that we talked about, just so you can double check that your answer actually is correct. Okay, this one, GCF, same thing. You should always look for a GCF, see if there's anything that all of the terms have in common. So between 5 and 20, they're both divisible by 5. And between a squared and a, they're both divisible by a. So in parentheses, you should write the leftovers. When you divide this term by 5a, you're left with another copy of a. And when you divide this term by 5a, you're left with a -4. Okay, equals 0. So remember, this is one factor. This is the other. So you can take each of your factors and set them equal to 0. And then solving will give you your answer for a. So here, divide both sides by 5. You end up with a equals 0. That's one answer. And here you'd add 4 to both sides. And so we end up with a equals 4. That's our second answer. Okay, usually you're going to have 2. Sometimes you might have 1 or even none. So now these ones, we're going to be solving kind of using the more general method for, we call these trinomials. There are 3 terms. So this one, you're going to set up 2 separate sets of parentheses. These ones specifically are not GCF problems, but you should always always be looking for a GCF no matter what method of factoring you're trying to use. So this one, what you're going to do, remember, probably more than likely it's going to end up looking like this. Okay, so what we do is we're kind of reversing that foiling process by knowing that I must have had two sets of parentheses like this to come out to be equal 0. So reverse that foiling process just like we did at the beginning part of the video. So if we have x squared right here, the first term is x squared, that means this times this must have given me x squared. So the only way to multiply to x squared is x times x. Okay, so I know that. And then when you think about how the rest of it works, this times this is supposed to give me 9. But more specifically, you're supposed to end up with a negative 6 in the middle. So first thing I want you to pay attention to, if I'm multiplying to a positive 9 and adding to a negative 6, that's going to be a negative number times a negative number. So we know that much. And then multiplying to 9 and adding to negative 6, that would be negative 3 and negative 3. They multiply to positive 9, they add to negative 6, so those are your two factors. Now notice the two factors are exactly the same, so you really just need to take one of them and set them equal to 0. Okay, so add 3 to both sides, and that will leave you with x equals 3. So what you could have done over here, you could write it like this. Since there's two of them, you could write it as a binomial squared. So we actually call this a perfect square trinomial since it factors down to be a perfect square like that. Okay, let's look at another example. Remember I mentioned up here that you have to have 0 on one side of the equation. So this one's not ready to factor yet because it still has a 36 on that side. So start by subtracting the 36 from both sides, and then that way you'll get 0 on one side. We can't start factoring until we have 0 on one side like that. So now there's no GCF. These two terms don't have anything in common. So we go right for our two sets of parentheses like this. This is a y squared, so that must be y times y. So y times y would have given me the y squared. Now this one's a little bit tricky. See, there is no middle term. There's no x term like this one has. So think of it as 0. So we're trying to multiply to a negative 36 and add to 0. So if I'm multiplying to a negative 36, that means one number must be negative and one number must be positive. So the two numbers that multiply to a negative 36 and add to 0, that would be negative 6 and positive 6. We call this the difference of perfect squares pattern. Okay, so that's the difference of perfect squares. Write that down. We can just call it the difference of squares. So difference means it's set up like subtraction, and there are just two pieces and they're both perfect squares. So this only works if you have a perfect square value right there. Okay, so now we set them each equal to 0. Set y minus 6 equal to 0. Set y plus 6 equal to 0. So here if I add 6 to both sides, I get y equals 6. Here if I subtract 6 from both sides, I get negative 6. So two solutions. And remember, it could happen that you might have one or even no solutions. All right, let's look at these ones here. So now these ones, these are kind of our easier ones with the x squared. These are going to get into more complicated territory here. So no GCF, always check all your terms to see if there's anything they all have in common. They don't, so I'm going to start setting up my parentheses. The only way to get just a plain old x squared is to start with x times x. And then we are trying to multiply to negative 15 and add to negative 2. Okay, so multiplying to negative 15 means one's negative, one's positive. And then the fact that this is a negative number overall means the negative number must be bigger. It's like the negative number wins out and makes the 2 negative. So multiplying to negative 15, that would be a negative 5 and a positive 3. Those two numbers multiply to negative 15, and then when you FOIL them back out, you end up with your negative 2x in the middle. Okay, so take each piece, set them equal to 0, and we will have solved. Okay, so here add 5 to both sides. So we end up with x equals 5 as our first answer. And then here subtract the 3 from both sides. And so our second answer is negative 3. Okay, another one kind of on the easy level. This is just an x squared, so I know I'm just going to have two sets of parentheses. There's no GCF among these three terms. So the only way to get an x squared is x times x. I'm multiplying to a negative 21, so I know one of these will be negative, one of them will be positive. And I'm trying to multiply to a negative 21 and add to a negative 4. Okay, so 21 is 7 times 3. So that would be a negative 7, because the 4 is negative, and a positive 3. So think of refoiling this out. X times x gives me x squared. That's why I put these numbers there. And then I know that these multiply to negative 21. What we're trying to check is the middle term. My middle term, I have a positive 3x plus a negative 7x. And that's how I know I get my negative 4x in the middle. So set these equal to 0. Okay, so for this one, I would add 7 to both sides. And then for this one, I would subtract 3 from both sides. Okay, that's the easier level. Here we're getting to the more complicated level. All right, so these, anytime you have a number right here in front of the x squared, it's always going to be harder. Okay, so what we're going to do in order to solve those ones is we're going to do a method called guess and check. So guess and check quite literally means you guess to see if it's the right factoring, and then you guess and then you check to see if it's right. If it's not right, then you start over. So it's going to be a little bit trickier and takes a while to get used to, but I'll walk you through how it works. Okay, so start with your 2 sets of parentheses. There's no GCF. There's nothing that 15 and 8 and 1 all have in common besides 1, of course. So you know how I chose this? I chose x times x because I knew that would give me an x squared. So for 15x squared, this term times this term, they're going to multiply together and give you a 15x squared. So you have 2 options. It could either be 15x times x. So 15x times x would give you 15x squared, or 3x times 5x. 3x times 5x. So this is literally up to you. It's a guess. You're going to guess which one you think would be right. Okay? So I'm going to guess that it's 3x times 5x. At this step, you can't do anything wrong. This is still just the guessing step. It's the checking step that's important. Okay, so now take a look at this positive 1. This term times this term is supposed to multiply and give me a positive 1. There are only 2 ways to multiply to a positive 1. Either 1 times 1 or negative 1 times negative 1. Your last clue that we have is this middle term right here. Because that's a negative, I know that this is going to be negative and this is going to be negative. That's how I multiply to a positive and add to a negative. Okay, and then, like I said, 1 is really your only option here. So we are not certain yet if this is correct. Let me show you the check step. Okay, so to check, you FOIL it all back out, kind of start over. So 3x times 5x is 15x. And that's a good start, but I already knew it was going to give me 15x. That's why I chose these values. And then 3x times negative 1, negative 3x. Negative 1 times 5x is negative 5x. And negative 1 times negative 1 is positive 1. So we know that these match up with these because that's the way we chose the numbers. What we're not certain of is whether the middle number actually works out. And with this one, it does. If you were to combine these up, negative 3x minus 5x, it does give you negative 8x. So that means we guessed correctly. So we don't have to redo it. And then we just go from there and set them up. So set up 3x minus 1 equals 0 and 5x minus 1 equals 0. Here I'll start by adding 1 to both sides. And I'll do the same thing here, add 1 to both sides. And then divide both sides by 3 here, and I get 1/3 after I divided both sides by 3. Here I'll divide both sides by 5, so I get 1/5. So 2 solutions still. All right, let's do this one last one here. So 5x squared, when I set up my parentheses, first of all, no GCF. There's nothing 5, 34, and 24 all have in common. So 5x squared, this one's at least a little bit better because there's only one option. The only way to multiply to 5 is 5 times 1. So it's going to be 5x times 1x. Okay, now here's the part that gets a little bit tricky. To multiply to 24, these 2 numbers are supposed to multiply and give me 24. So you've got tons of options here. It could be 1 times 24, 2 times 12, 3 times 8, 4 times 6. Okay, so let's choose 3 times 8. So remember, this is just a guess. So let's put 3 and 8. Okay, now we're going to check to see if this is correct. Here's the check step. 5x times x is 5x squared. 5x times 8 is 40x. 3 times x is 3x. And 3 times 8 is 24. Okay, so when I add these together, I get 43x. This is not 43x, which means this one is not correct. Okay, that's the default of the guess and check method, is sometimes you're not right. So I'm going to start with my 5x times x again, because I know that's my only option to get the 5x squared. Let's try 4 and 6. Okay, so 4 times 6, I know that gives me 24. Let's check. So 5x times x is 5x squared. 5x times 6 is 30x. 4 times x is 4x. And 4 times 6 is 24. Okay, so these, there we go. 30x plus 4x does give me 34x. So this one's right. Okay, so now let's set those equal to 0. So set 5x plus 4 equal to 0, and set x plus 6 equal to 0. This one's easy. Here I just have to subtract the 6. This one requires an extra step. So subtract the 4 from both sides, like that, and then divide both sides by 5. And there we go.